Thank you for your kind introduction. Ladies and gentlemen, today I'm very glad to share with you about the section of gas leak detection by LGD Compact module. I will start my presentation by explaining why gas leaks need to be measured and where this is important. After that, I would like to show you a few integration examples, some of which are in use in our customer side and in the portable leak detection examples. I will then go into the dual gas measurement of missing and etching. At the end of my presentation, I will show you a few grams of the performance of the new LGD Compact. Let me start my talk with a short video from National Geographic. Here is a leak of gas storage was recorded once with a normal camera and once with an infrared camera. This shows very well the importance of the good measurement technology in detecting gas leaks, because missing gas is not visible to the human eye. Now we start video. So, as you saw in the video, gas leaks, especially near populated area, can quickly become a hazard. Gas leaks also have serious consequences for the environment and the climate. But how do gas leaks occur? Mainly this is caused by defected gas pipes. Gas pipelines have a service life of about 40 years. There would be a lot of factors cause the damage, cracking the pipeline during the time and site conditions. In addition, most pipelines or tanks are made of very radioactive bacteria or compounds. Thus, they cannot compensate well for vibration for the earth or from buildings. So, in some areas, leak detection was mandatory required. Therefore, the regulation was set for this application in many countries, such as in USA, Europe, China, Asia. There are different regulations which were intended for such leak detection. If with gas leakage, the security issue will become very important. For example, gas pipe explosion in city will affect the security of lives and the property of the people. Secondly, it linked to the profit optimization at some industrial plants. Gas leakage means profit loss. And for example, the loss in US industries is estimated to around $2 billion. Finally, it also would be linked to environmental protection. Methane is a greenhouse gas, about 25 times stronger than carbon dioxide. You also can see these reference numbers. 9.8 million tons of methane are emitted in US gas chain every year, and 22 million tons in China. And where to measure these possible leaks? In principle, we can do in the whole industrial chain of natural gas production, such as natural gas extraction plants which belong to upstream process, and the gas transportation, gas storage at the receiving station. These are for midstream process, and downstream process which included the city natural gas pipeline network. For such possible leaks, we offer LGD Compact module for missing and also for missing and easing detection. We can measure leaks for transport pipeline, Fenceline Monitoring, city gas network. Customers can assemble our LGD Compact module into different devices to measure the leaks of the missing or missing and easing. It could be VQ mounted version, portable device, and even with drone driving. We will go into these examples from city gas leak detection in more details on the next slides, and also some research project. Customers need to measure the missing leakage under the subsea. The extractive sampling system was needed. Here you can see an example for gas leak detection installed in a car. At the front of the bump are mounted the suction cups that collect the gas in front of the vehicle. Here you can see the advantage of the TDLS technology. For example, if the vehicle is directly behind another car and sucks in the exhausted gases, there is no cross sensitivity to other gases when measuring with the TDLS. During the laser used, the measurement is very specifically focused only on missing. In addition, such vehicles are usually equipped with GPS system. Thus, a map is created during the journey where the highest missing concentration were measured. This makes it easier to locate leaks. Now, here is an example from one of our customers in China. The LGD Compact is installed in the box at the back of the electric motorcycle. At the front of the vehicle you can see again the suckers. They have created a short video of a test drive. The gas leak is located here in the manhole. You can hear the alarm when the device detects the leak. The last example is from a Danish customer. They installed the LGD Compact on a drone to detect emissions from biogas plant. As you can see, the suction tube here is relatively short, so more suitable for fugitive emission. However, with an adapted suction system, this integration could also be used for leak detection. Now let's have a look how the missing leak detection will be performed, and also to understand why easing may be also needed to measure. It's a simulation how to use LGD Compact for leak detection. In a normal daily work, the operator will use the leak detector to measure normal background level of missing and searching for a possible leak. And then he found a leak and looking for the highest concentration of missing. When the operator found the center of leak with the highest missing concentration, he will consider that what is the source of this leakage. So where does this missing come from? Do we have to do now expensive repair actions for this pipeline? These questions can be answered when we have a look at the composition of biogas and natural gas. The main components in both gases are missing, therefore a pure missing measurement device is not sufficient for differentiation. There are many components that differ in both gases. The main difference, however, is the easing. In natural gas, that can account for up to 10%. Since easing is close to missing in the infrared spectrum, it is therefore well suitable for detection. So now, when the operator measured the easing too, that he can confirm the source of leakage. It is a standard process for leakage detection, and Axetris can offer the LGD Compact to measure missing and easing within one gas model. There is no further equipment needed, and the easing measurement can be performed within a few seconds. Here you can see a measurement in our laboratory with an LGD Compact for missing. Ambient air was used for the flow gas. So you can see the natural missing concentration of about 2 ppm. Two small jumps can be seen. In each case, employees were in the laboratory and caused minimal turbulences. In the general course of this measurement, however, no drift can be seen. A frequent recalibration of the LGD Compact is therefore not necessary. Here you can see a measurement of methane from a gas cylinder. It was started with nitrogen, then the concentration was increased in very small steps of 0.5 or 1 ppm. And can be seen well here. The response time of the LGD Compact is very fast in each case, and the measured concentration is kept stable. In this diagram, we have a constant gas flow of 50 ppm easing and gradually increasing missing up to 1.5%. It is good to see that there is no cross influence from the missing, even at very low easing concentrations. This means that you can always rely on the result of the easing, even if the missing measurements fluctuate. As soon as the easing is measured by LGD Compact, the source is natural gas. This is where I would like to end my presentation. In summary, we can say that the TD-less technology and the LGD Compact are perfect solutions for gas leak detection due to its close interference-free measurement and the long-term stability. Thank you very much for your attention and looking forward to your questions. Bye bye.